between polar and rectangular coordinates. Well, you really need like the Pythagorean theorem. That's all you're doing to find the r value. So here's what you're going to do, right? R is the distance from the origin, so we're going to use the Pythagorean theorem to calculate r. Notice x squared plus y squared equals r squared, right? We've been talking about circles and the equation of a circle. It kind of does link to polar because we're talking about an r value, the radius of a circle on the unit, plane. And then the angle theta can be found using the inverse tan. Remember when you do tan to the -1 on your calculator to find the angle measure? So just to practice, how would I find, if I plot the point, this is rectangular point, -3, 4, how do I plot this r value, right? This is 4, this is -3. Here's my r value, and here's my angle for that triangle. For my polar coordinate, this is really the angle that I'm interested in though, right? This line is opening up from here. Right triangle trig, I'm going to find this angle first. So to find r, you're just going to do a squared plus b squared and then take the square root because r is the hypotenuse, right? So 3 squared is 9 plus 4 squared is 16. So together they're 25. Yeah, but -3 times -3 as a distance is still +9 because it's a side of a triangle. So negative times negative. But the square root gives me an r value of 5. Would you believe that, right? And then the angle measure, when I take the inverse tangent of 4 over -3, right? Because it's opposite over adjacent. We can do it in degrees on our calculator. You can do it in degrees or radians. I'm going to do mine in degrees. You have to be a little bit careful because what is it? Does everyone know how to do inverse tangent on their calculator? It's hard to see on mine. Let's see. Right, it's the second tangent button, and I put mine in degree mode. So 4 over -3, it gives me an angle of -53 degrees about. So that tells me that this angle is 53 degrees and it's negative because I'm in the second quadrant where tangent is negative. How do I find this angle? I think you want to subtract this angle from 180. So you actually, if it's 53 degrees, you're always going to get 53, but based on which quadrant you're in, you might have to add or subtract 90 or 180 to get the correct angle, right? Because this has to open from the origin, get to here, and have 53 degrees remaining inside this triangle. So you actually need to take 180 minus 53. As long as, yeah, 180 plus -53, yeah. So the angle is 127. So that coordinate is 5, 127 degrees. And that would get you to the same point as -3, 4. But there's multiple correct answers, right? Because I could add 360 to that and get a coterminal angle. I could throw a -5 in here and find whatever angle is over here on the other side of that 180. So there's multiple correct answers. All right, so let's try some of these together. So don't overthink it. If I'm at 0, 5 as my x and my y, don't I know what angle that is? And don't I know how far away I am from the origin without having to do Pythagorean theorem? How far away am I from the origin? 5. So my r value is 5, and I know that angle without doing any work. 90 degrees or pi over 2. So I don't need the challenging conversion factor of Pythagorean theorem or tangent if it's a quadrantal angle, right? Because it's going to be the same distance as the x or y value is. All right, example 6. What if I'm at +2 on the x-axis and -2 on the y-axis? So I'm down here. So got to think about your triangle. The first thing is to find your r value. You're going to do the Pythagorean theorem, right? 2 squared is 4. Another 2 squared is 4. So it's the square root of 8. Does anyone remember how to reduce the square root of 8 from your trig course? So you look for it's 2 root 2. You look for a perfect square. Square root of 4, square root of 2, so it's 2 root 2. So if you want to leave it as the square root of 8, that's fine with me, but just keep in mind, that's equivalent to 2 root 2, and on the SAT, they might throw 2 root 2 as the answer instead of root 8, just they're interchangeable. And what angle is that without doing much calculation? How did you know that this angle right here is 45? It's an isosceles right triangle. 45 is not the correct answer for this angle, though. You could either call it positive 315, you could call it negative 45 or negative pi over 4, right? So pick an appropriate answer. So either negative 45 degrees, positive 315 degrees. If you want to be fancy and answer in radians, that's fine. Negative pi over 4, or what would it be? 7 pi over 4 would be 315.
Why did they give us in the number 9? Why did they give us the exact?
Typo. Sorry. Wow, you already did number 7?
No.
Oh.
Where did my pen just go?
Really?
It literally just teleported. It's gone.
Okay. Number 7. So if I'm at 1 comma 5, so this is going to take a little bit of calculation because I don't know the inverse tangent. This is not a special angle. I don't know the Pythagorean theorem for this one. So do your calculation. See what you would get as r. And then you're going to do inverse tangent of opposite over adjacent and get the angle. Don't say it out loud for a minute. See if people can record their answer. R theta. If you want to leave it as a reduced radical, if you want to put the r value as a decimal, either one is fine with me. So when you do a squared plus b squared and take the square root, what did you get? You can either leave it as the square root of 26 or 5.1 if you rounded it to a decimal. That's your r value. Remember, your r value should always be longer than x or y because it's the hypotenuse. And then when you do inverse tan, what do you get? Yeah, about 78.7 degrees. And that's in quadrant 1. You're doing the inverse tangent. So the tan, the -1 key. If you start with the ratio, you have to go backwards to get the angle. So it's going to be inverse tan in this direction. Yes? Yeah, you don't have to do number 9. Okay. Number 8 should be kind of a quick one because it's a quadrantal angle again. So -10, 0 is located over here. You need to figure out how far away you are from the origin and what angle gets you there. So what would you say for this one? Well, it's putting together a whole couple units of trig and solving problems with them in a new way. So maybe it's just reinforcing the trig that you learned. So my r distance is 10, and my angle would be what? What would be a good answer? You could use 180. You could use -180. You could use pi or negative pi or 3 pi, right? There's multiple correct answers for that angle. You could also do -10, 360 degrees, right? Because that goes over here and then walks 10 in the negative direction. So you could play around with using r values too. All right, so cross out number 9. All right, so why don't you try 10 and 11 if you haven't yet on your own. I'll pause for a minute, let you try them. So here are some answers for 10. Choose one of the r values, either the square root of 52, 7.2, or 2 root 13. And the angle should have been about 56 degrees, which Ethan did it on radian mode and it came out to 0.98. Remember we said 1 radian is about 57 degrees. I think we did that conversion factor last class. And then Pythagorean triple, right? So the R value is 10. And then 127, you should have gotten what? Negative 53. And then that reminded you that, hey, we had negative 53 up here and it was 127. It's the same reference triangle, right? A 4 and a 3 ratio is the same as an 8 and a 6 ratio, right? So that is converting from rectangular into polar. I've got 5 minutes, so I want to show you polar to rectangular because after your quiz next class, you're going to do some of the guided practice on this. So I want you to know how to do the